Hello. In this video, I'm going to show you how to test your high-speed internet connection for speed and reliability. Usually, most people are connected to the internet using a cable or DSL modem, as you see here on my diagram. Now, what we need to do to test the speed of your internet connection is to isolate the modem to a single node. In other words, what we're going to do is connect a laptop or a PC directly to the modem and using a network cable like this one. And preferably, it should be a Category 6 cable. If you don't know what version of cable you have, then it should, usually it's printed right on the cable itself. You can read it right on it. It'll either say Cat 5e or Cat 6 or higher, or if it doesn't have any printing at all on it, then more than likely that's a Category 5, which is not really recommended for this test. You should have a 5e or a Cat 5e or Cat 6 cable to do this connection. And what we're going to do, and here, let me show you the next slide. There we go. There's all the categories of network cables, and you can see here that the Cat 5 is, only recommended for 10 to 100 megabits per second connection. Anything higher than that, and it won't work reliably and won't give you good speeds. So Cat 5e, Cat 6, or Cat 6a, if you wish, are what I would recommend for a high-speed internet connection. Again, check the cable, look at it, the printing, and if you don't have it, go get yourself one, and I'll put links to that stuff in the video description below. Okay, so what we're going to do is isolate your connection by connecting directly to your modem. And let me change the slide. Now, here's a bunch of different options for these modems. We've got the standalone modem, which is what I have right here. I have a cable modem, but some people can have a DSL modem, and some people can have a fiber modem. But I'm going to deal with cable and DSL here, just to be specific. And what we're going to do is connect directly to the port on the back of the cable modem, to your PC or your laptop using the network cable. Same here with the DSL. You see that there's one output Ethernet port on either one of these. Now, there is a variable on these things. You could have a cable router combination, and that complicates things a bit. And part of the reason why we isolate the connection, why we connect directly to the modem, is to stop any other network traffic from going through at the same time that we're testing. What that does is it actually, it gives you a true performance number. But if you have a cable or modem, a cable modem or a DSL modem router combination, as you see here on the right, well then you're kind of stuck because basically you can't separate the router from the modem. It's all internal. So the best way to test that out is to disconnect anything connected to the ports other than the PC or laptop that you're going to use to connect to it. Same here on the DSL modem. These ports, these are the Ethernet ports. We're going to disconnect everything from those. And if you know how to disable the wireless on your router, then do that. Other than that, I would say just turn off all the other wireless devices that connect to your cable modem router. And again, how can you tell if you have one of those? Well, as you see in here in the picture, one has 4 ports and the other has a single port. And basically your router connects to the single port on these single port modems. And on the cable modem, you won't have a router. You'll just, on the cable modem router combo, you won't have a router. You'll just have one connection, the cable going into the same box as is your router, as you can see here on the video. Once you connect directly to the modem, then we can commence testing the connection. And I'll show you how to do that next. So once you've connected your LAN cable directly to your modem, as in this case here, I suggest power cycling your router, your modem. If you have a power switch, just turn it off and back on again. If you don't, unplug it, plug it back in, and basically do a reboot of that device to start fresh with it. Also reboot your laptop on the other side of this connection to make sure that it's fresh as well. So we're going to start with a rebooted laptop and a rebooted modem, and it may take a little while for your modem to come back online. So give it 2 or 3 minutes, and after it's back online, we'll continue the testing from there on. So if you've got one of these modem router combos that I'm showing here on the screen, like the ones on the uh, right here. If this is what you're playing with or what you're dealing with, make sure that you turn off all wireless devices like tablets and cell phones that are connected to your router, or put them on airplane mode or whatever way you disconnect them from Wi-Fi. Because unfortunately with those combo devices, the router is integrated into the modem, and basically it's always listening for data. So unless you know how to disable the Wi-Fi on the router itself or the modem router, then the best bet is just turn off all your wireless devices so that they no longer connect. Again, also disconnect any LAN connected devices to the ports, and then reconnect them after the test is over. Primarily, we want to isolate the data to one computer connected to your modem, and that's it, so that we can get a reliable speed test. If these things here are on and they're updating or downloading stuff or whatever, they're going to affect your speed, and you don't need that. So again, turn these all off, all the Wi-Fi devices and all the network connected devices off. Okay, we've got all the preliminary work done. The Wi-Fi devices are all turned off. We're connected directly to the modem from the PC or laptop. And if you've got a combo modem router, we're the only device connected and turned on in your network. That should be the way it goes. And then once you do that and you power cycle the router, you should have a connection down here like this one, Ethernet connection, as you can see. I'm going to click on it, and you can see that my Wi-Fi is still on here. So I'm just going to click this little tab, the Wi-Fi button here, to turn off Wi-Fi. That way we know we're only connected to the modem or the network through network connection or the LAN network connection. So at this point, we want to check and see if we're on the internet. So I'm just going to open up a browser tab. And I'm going to go to my favorite speed test. So I'm just going to type in speed test into the address bar, and that will, in my case, search Google. So Google search speed test, and then the first one that usually comes up is speedtest.net, which is what I use. So click on that, and here you'll see speedtest.net come up, and it will tell you your IP address. It will tell you your, what server it's going to use, and basically that it's ready to go. So all you need to do a speed test right now is click go. I'm not going to go through that process because I've already done that. So let me just open up my image. Okay. And I wanted to show you something. Okay. This is my speed test for my 100 megabit per second account with Spectrum. And you can see that I'm getting a little bit more. I'm getting 120. And I'm supposed to get 10 megabits upload. I'm getting 11.59. So they're over delivering, and I'm very happy with that. Ping test is 23, which is pretty decent. Ping is what they call your latency, and ping is important for gamers. They want as low a latency as possible so that they can get the draw on their opponents on their online games. But for me, ping is kind of nice, but it's not really all that important. Download speed is important to me, and upload speed is important to me too, because I'm a video YouTube creator and I'm putting uploading these videos to YouTube, and I don't want it to take 3 days. And at 11.59 megabits per second, it's pretty good. So this is my speed test, and you can see that the server is close to me, College Station, and the IP address is the same. So again, I'm not worried about putting my IP address up here because it's going to change the next time I reboot the router anyway. So if you look here, you can see that you can change the server that you're using the test with. So maybe you can play with that and get a better result. But personally, I find that it does a pretty good job of finding the right server. So there's my result. You click on that go button and see what your result is. Again, you need to know what your internet provider is providing you. So again, I think if it's within 10% of what they say that you are supposed to get. In other words, if they say you're paying for a 100 megabit connection and you get 110 like me, that's within 10%. It's actually 10% over. And if it's 10% under, again, that's still cool. It's still okay. I mean, cable connections are sort of dependent on how much traffic is in your neighborhood. The more neighborhood traffic you have, it will actually slow down your connection somewhat. But you should be within 10% of what you're paying for. And if you're not, then I'll show you a few tests on how to detect what's going on. At worst, if you're getting like 50% of what you're supposed to get. In other words, if you're getting like 50 megabytes per second and you're doing this test, then I would call your provider and say, hey, what's going on, right? Why am I getting such a slow speed? I'm paying for 100. Shouldn't I be getting 100? I mean, that's the way I look at it. If you buy 10 gallons worth of gas, you should get 10 gallons worth of gas. You know what I mean? So if you're paying for a 100 megabit connection, you should be getting a 100 megabit connection. Now, another thing I want to show you as a possible problem with speed, especially anything over 100 megabits, is the cable. Now, on my next slide, I'm going to show you the tests with a Cat5 cable, not a Cat5e, but Cat5. If you look at these cable standards that we have here, we've got Cat5e, Cat6, and Cat6A. You should have no less than a Cat5e. But with a Cat5 cable, which is rated for 100 megabits and below, then you're not going to get reliable speeds over 100. So I just wanted to show you what difference that cable between you and your devices makes, right? Or you and your modem makes. So here you'll see that test. There's the test I get with a Cat5 cable, right? Get a decent ping, that's no issue. But the download speed is 93.99, which is almost 20 megabits per second slower. Upload speed still okay at 11.55. Why? Because the cable can easily handle 11 megabits per second. But it cannot handle more, in theory, than 100 megabits per second. And obviously, it's even choking it lower than that. So the cables you're using on your network are essential. They need to be the right categories. And if you're over 100 megabits per second speeds, like a gigabit network, you should be using at least Cat5e cables. And I strongly recommend, even if you're using Cat5e cables, to upgrade to Cat6 cables, because they're much more reliable and they're quicker. They really will make a difference, and they're worth the little extra bit that you have to pay for those cables. Again, I'll put links for that in the video description below for everybody. So there's my tests, and they're decent. Now, the next thing you need to do is if you got a decent test, is see how reliable your connection is. Sometimes you get a decent test, or sometimes you get a really bad test. And I'll show you the difference here with cable after. Okay, so I put the Cat6 cable back on, so I should be getting this kinds of speeds. So I'm gonna hit the button here and go. See what kind of test I get. Now I know my connection's reliable and pretty good, so I don't suspect there'll be any problem here. And there you go, more or less up where my original tests were with the Cat6 cable. Again, over 100, and I'm paying for a 100 megabit connection to the internet, so at 111.34, I'm very happy. So, again, I have a reliable connection and it's perfect. Now, if whatever you're paying for, if you're not getting within 10% of that speed, at least on the lower end, then I would say you've got some sort of connection issue, some sort of speed issue, or some sort of provider issue, because, really, as I said before, you should be getting what you pay for, as far as I'm concerned. If I buy $10 worth of gasoline, I want $10 worth of gasoline. I don't want 9, right? So, if you're paying for a 100 megabit connection, you should be getting the 100 megabits, regardless of whether they guarantee it or not. Again, kind of hard to test the perfect connection like I have, but I'll show you the steps that you got to go through with that. So as you can see, my test is very nice. Ping 18 milliseconds, 111 megabits per second, and 11.43 megabits per second on the upload. So the download is fast, the ping is fast, and the upload is fast. Perfect for me. So, I kind of wish I had an unreliable connection so I could show you how that works. But I'll show you how to test for reliability. So go down to your search button next to your Windows command here, and if you don't have that, just go to the run command. But what you're going to type in is CMD, And you can run it as an administrator, or you can just run it regularly. I'm just going to run it as a regular user. So just click on that, CMD, that's command. This is the DOS shell showing you the DOS commands. Now, there's some basic network testing protocols or tools which are very, very useful, and all network professionals more or less use them to test. The first tool is called ping, and the second is called Traceroute or Tracert in Microsoft's world. In Linux or Unix, you would be using Traceroute, but regardless, they both do the same thing. So here what we're going to do is we're going to type in ping space T, and the T will make it a continuous ping until you terminate it. And then we're going to ping my favorite servers, which are Google's. Obviously, very robust servers, which are always up and very reliable. And there's no problem with pinging servers on the internet. It's not illegal. It's not a hack or anything like that. You're just pinging, and that's a normal feature. So, you know, don't worry about doing this. It's standard protocol for most people or most professionals who test networks. Anyway, so here we're going to hit ping, and you can see I'm getting a reply from that server without any issue at all. Now, the reason I'm showing you this is because the ping test shows you reliability. If you're not getting a response from a ping test, or you're dropping packets, or you see, you know, 1,000 millisecond times in there or higher, and 1,000 milliseconds would be a second. That's very, very slow, and there's something wrong with that. So, so again, if you're losing packets, if you have really, really long times on those on this screen, then more than likely you have some sort of networking issue. So here I'm just going to hit Control C. So that's the Control key and the C key on your keyboard, and that stops the ping, and it gives you a breakdown of what I just did. I sent 48 packets. I received 48 packets. I didn't lose any. And that's, as far as I'm concerned, that's the way it should work. Now, if I ran this test for hours, I may lose one or two here and there. But that's, you know, totally acceptable. You should have less than 1%. In fact, I would say a tenth of a percent lost packets should be your maximum. If you have more than 1%, packet loss, there's some sort of problem on your network, or there's some sort of problem between you and the device you're pinging, right? So Google servers shouldn't be a problem. So let me show you the second tool to test networks with, and that is Traceroute. So we're going to just type in Tracert, which is the way Microsoft does this command. So Tracert, and then www.google.com, and then just hit enter. Now what this does is it shows you the hops between you and the Google server. And what I mean by hops is usually just routers. These are the routers between your computer that's you know, we just used to ping Google, and Google. So again, this is a way of testing your connection. Now it says trace complete. There's 8 hops between my computer and the Google server that I pinged. So, and they all have IP addresses, as you can see here on the screen as well. But the really important one is the first hop, right? If you're losing packets, if you have latency issues, if you have you know, speed issues, then there's some sort of you know, problem with your network, especially if you're paying for 100 megabits and getting maybe 50, or your ping time is really, really high. There's some sort of error or problem with your network, and this basically helps you to troubleshoot that. The ping test should return 0 lost packets, but if you're losing a lot of packets, there's some sort of reliability issue. Now, you can see these 8 IP addresses, and if you want, you can go and check you know, who these IP addresses belong to individually at a site called Aaron. But you know, again, it's irrelevant. What really matters in this test starting is the first hop. So if you had an unreliable internet connection, or you're pinging Google and you're losing a lot of packets, then you want to start pinging from the closest hop to the furthest hop to see where the error is happening. So if I go and I ping 24.162.128.1, that is the first hop between my computer and Google. So I have to assume that would be my internet provider. That IP address belongs to my internet provider because they're the first hop between me and the rest of the internet. So if you know, again, we would just do a ping on that. So ping, and I'll just highlight that, copy it over here, and put it down here. So you just highlight it, right click it, and that copies it, and then you just right click down here and it comes back up again. So at this point, what you would do is the exact same test again. So -T and that IP address, and then you run a bunch of pings, and you let it go and go and go and go. And if you find that you're losing packets on that IP address, the first hop, I would certainly call your internet provider and say, hey, there's a problem between me and you. I'm losing like 50% of my packets that I ping onto you, and that means there's something unreliable between you and your provider. Now that could be anything. You could have a bad modem. You could have a bad network cable between you and the modem. So, you know, change the cable. Maybe you got a bad network cable between your computer and the modem. You could have, you know, a bad coax connector on your cable modem. You could have a bad coax connection somewhere out in your, on the box on the outside of your house that connects you to the pole. It could be anything. But if you're losing packets between you and the first hop, there's a problem between your computer and your internet provider, and that needs to be fixed somehow. So I would go with, you know, what you can actually control. Change the network cable between your computer or your PC and your laptop and your modem, and try it again and see if that fixes the issue. If that doesn't do it, then there's something wrong after the cable, which means it's either your modem, your connection from the modem to the pole, or somewhere in between. But I would certainly at that point, once it gets out of your hands, which is like beyond your modem, you know, beyond the cable that you connect to your modem, I would call your internet provider and see what happens. So let's do Control C, and you can see I didn't lose any here. Obviously, my connection is reliable all the way to Google, so we don't have that problem. Now, I can simulate a poor connection and show you how, you know, this all basically shakes out from a non-working, network connection. But basically, what really matters here is when you go back is your first hop, right? So let's say we did this test between, you know, we did this test to ping Google, and again, you know, you do the ping test on the first IP address and you don't lose any packets. Well, okay, then you do the ping test on the second IP address and you don't lose any packets. Wherever you start losing packets, that's where the problem is, right? But, you know, really, once it's outside of your first hop on, you know, in other words, from you to your internet provider, like say you don't lose any packets pinging the first IP address, you lose it with the second or the third or whatever, I'd call them up and say, hey, you know, I'm pinging Google and I'm losing packets and it's on this IP address. Is there anything you guys can do, right? Or try pinging a different server like Yahoo or, you know, somebody else that responds to a ping. Most of them do. Not everyone does, but most of them do. Okay, one more thing here you guys may have noticed is on the 7th hop, you get these stars and a request timed out. Now, not all routers are going to respond to a Traceroute or to a ping request. You can shut that feature off on the router. You can say, hey, router, don't respond to these requests. Just, you know, drop them, right? But so the 7th hop on this Traceroute is not responding, but that doesn't matter. It doesn't mean it's not working because it actually, you know, the 8th responded. So beyond the 7th, you still got a response. So it just basically means that the 7th hop on this trace is shut off or is not responding to this command. So Yeah, I think I'll set up a unreliable network that drops packets for you and show you a real world test where you can see, the packets dropping and determine where that is actually happening. So through a little bit of work, I've managed to create an unreliable private internet network using my four routers daisy chained together, and bit of a task actually. I was surprised, but I mean I have very reliable hardware, so creating an unreliable network connection is a bit of a trick. So what I did is I connected four routers together. The last router has Wi-Fi turned on, and I connected a Raspberry Pi B plus to that router using Wi-Fi. I had to put the router is directly behind me in this chair, and I had to put the Raspberry Pi 50 feet back in my backyard, inside a steel shed with the door almost completely closed, to get it to become unreliable when it's connected to this Wi-Fi router behind me. Incredible. So I got to hand it my hats off to the Raspberry Pi B Plus. Seems to have an incredible Wi-Fi antenna. But regardless, let's do the test again. So go back to your start search there or your run box, and then type in CMD, hit enter, gets a DOS window, and then we're going to ping that IP address with a T. So dash T, and then 192.168.3.123. That's the IP address of the Raspberry Pi B Plus. Here, normally you would be pinging Google, www.google.com, but I can't make Google unreliable, so I made it unreliable, and even then, incredible. Still giving me a pretty solid reply on my ping test. And I'm hoping it's going to drop some packets here. And if it doesn't, here's what I'll do. I'll move it closer to the floor, and then hopefully the router will start dropping packets. It's just incredible, as I said. Hard to believe. Oh, there we go. So we're getting a request timed out. That means that it's dropping packets. But it's still able to connect with I've got the antennas folded flat to the floor, the router on the floor, two walls, interior walls, and a third exterior wall, 50 feet out to the shed, about 60 feet away from where I am right now, maybe 70, and it's still able to connect to this router behind me on the floor. I mean, Raspberry Pi B Plus, awesome Wi-Fi antenna, I gotta say. So here, we're getting our requests timed out, which means it's dropping packets, which means it's an unreliable network connection. So you can see here I've lost 7 of 26, making a 21% loss, and totally unacceptable. Like I said, if you have more than a 1% loss, you should be calling your internet service provider once you check to make sure that it's not your cable internally, by pinging, by changing the cable and making sure that it's good. So at this point, if you were pinging Google and it wasn't reliable, you would type in Traceroute space. In this case, my Google is 192.168.3.123, and that's the Raspberry B Plus. And it's just going to go through the hops. The four routers I've got hooked up until it reaches the actual router itself, or the device itself. So you can see I've got one on a 10.00.1 network, a 192.168.1.1, a 4.1, and then the last one is the 3.123. So at this point, you'd ping all three of these, actually all four of these IP addresses. I don't really need to ping them, but here I'll just do it preliminary -T 10.0.0.1. And you'll see that that's reliable. It won't drop anything. You would ping every single one of these with the T command and see if which one of the connections are unreliable. But really, in this case, the one that you really need to worry about is your primary. Let me do that. Seem to have lost it. There we go. You'd be pinging the primary network, which is 10.0.0.1, and it should be reliable. And if it's not, then there's something wrong between your PC and the internet, and you need to get it fixed. In which case, I would say call your internet service provider. Make sure that your cabling to the router or to the modem is actually reliable, and then say, hey, why am I dropping packets? Why is my internet slow? And they'll go through the troubleshooting with you until you find out what actually is the problem. But they should be able to see the same thing you're seeing, which is packet loss and your speed not being good, and basically your quality of connection to the network being inferior. So that's it for my video on testing your internet connection, your modem connection to the internet, and your speed. And again, when you went, even if everything's cool, after doing this test, one thing you're going to know, let me open this up, and is your baseline. So let's do the speedtest.net again. What you're going to know is your baseline speed to the internet. Now, this one's not going to be good because I got 4 routers between me and the internet, but I'm sure it'll still be pretty good. But regardless, if there's no problems with your connection and there's no speed issues, no packet drops or basically speed issues, you're going to have a baseline knowledge of how fast your internet connection speed is. And from there on, you can basically understand what kind of speeds you should have from the rest of your network. But again, like I said here, this is not really a great way of testing it because I've got some really slow routers hooked together, 4 of them in total. And yeah, that's going to slow down the network a little bit. But in your case, you'll get a baseline and you'll know exactly what your speed is. And you'll know whether you're getting what you're paying for, whether it's reliable with the ping test, and where it's breaking down with the Traceroute test and ping test put together. So that's my video on testing your high-speed internet connection. Hopefully that helped you. If you like this video and it helped you out in some way, do me a huge favor. Give me a thumbs up down, I believe, on the bottom right. And if it helped you and it might help somebody else, share the video. I would appreciate that. Also, you'll see on the screen a picture of me. That is a subscription link. If you click on the subscription link, and as part of that, clicking on that link, you'll get a bell icon. That's the notification bell. Click on the notification bell if you want to be notified whenever I put up a new video like this one. Once again, thank you for watching, and be the best version of yourself.